right, thanks very much. Very happy to be there. It's probably my, I think my 6th KCD this year. It's been a great community, so I'm very, very humbled to be there. And I see like every time so many experts and also beginners. And I just love this community. And to be honest, maybe I shouldn't say, oh, it's recorded. Or maybe I shouldn't say that anyway. But I tend to prefer these local events rather than KubeCon. So hopefully they're going to continue to develop over time. But yeah, I'm very happy to be there. So the topic for today is going to be focused around admission controllers, the good, the bad, the ugly. So yesterday there was a talk about webhooks, what could go wrong with them. So there shouldn't be any overlap with that. Because we're going to be focusing on building an admission controller in Go, a mutating admission controller, where we're going to be adding a label with random Marvel character taken from the Marvel APIs. And as I know, the span of attention of a human being is probably between 10 and 20 minutes. And if we add all the notifications, the smartphones, probably reduced to 5 to 10 minutes. So I've divided the talk into 3 different sections. First is, pick your poison, right? If you're new to Kubernetes, don't know much about admission controller, the first part is really what is admission controller, why they are useful, all these kind of things. Second one is a bit more Go code into how to build this in Go with a quick demo with this Marvel webhook, and then some best practices, common caveats, and things I've learned along the way. So before going in, quick introduction myself. I'm Nic. I'm doing everything DevRel at SpectroCloud. I've been working with Kubernetes for the last 6 years in the industry of IT, software development, virtualization, networking for about 20 years. Yeah, I turned 43 a couple of days ago. So yeah, getting old is not it is not good, but I guess it's experience, right? Anyway. So I like coding, metal, running, and World of Warcraft. Probably World of Warcraft a bit too much, which probably means I know WoW better than I know Kubernetes, which is a bit scary. Anyway, so let's get stuck in. What are admission controllers? So in essence, they are a Kubernetes component that enforces governance within the cluster. So they can be validating or mutating. Validating, so they can determine what objects can be deployed in the cluster, or mutating, meaning that they can optionally alter some of the object's properties. Can be paths, can be any other things. And by default, they are enabled using the API server an argument, which is -- enable admission plugins. And they can be static or dynamic. Static means that they are compiled as part of the Kubernetes API server. Dynamic means that the API server is going to send an admission request to webhook server, and then is going to expect a response back, with a particular object that we're going to see in a minute. And these external webhooks can be in or out cluster, because essentially they are, just web HTTP server. Typically, you run them in cluster, but you can, also run them outside of the cluster. There are a couple of design decisions. It's not the topic of this talk, because this is sort of a rat holes. Yesterday we've seen, anything that can go wrong. This is really not the topic for today. Half an hour is definitely not enough. So fundamentally, why do we need admission controllers? So at the beginning, very basically, some native features are depending on it. Things about, when you clean up a namespace, you delete namespace. You want to, you have a service account associated with your pod that is running. All this sort of automation is done by, under the hood with this admission controller. So namespace lifecycle, limit ranger, to make sure that the cluster, comply with the limit you set on your pods. Service account automation, all of that is enabled by default through the enable admission controller, the plugin. So if we don't have an admission controller, you don't have a full functioning Kubernetes cluster at the very foundation. So of course, security compliance, the PSP, PSA now is depending on the admission controller. Resource management, as I mentioned, but also it's a way to implement custom logic and operational best practices. that are specific to your organization. So complex validation or mutation logic, like what we're going to do today, proper labeling, although I'm not sure like adding a Marvel label is really like a good idea for production. But anyway, annotation, resource configuration, you can do all that. If you want to enfold this into your cluster, you can do this using dynamic admission controls. And they are, of course, off-the-shelf solution. Pretty well-known one is OPA Gatekeeper or Kyverno. So with Kyverno, you can do anything you want pretty much in terms of testing your YAML manifests, modify things. It can be mutating, validating. You can do that in cluster, so in the form of the admission controller, but also via a CLI, so you can test the policy against manifests. With Gatekeeper, it will be a bit more convoluted because you need to add a Rego in the picture. I know there are some Rego fans there, but yeah, it can be a bit more complex. So the question becomes like, why would you want to do a custom admission controller from scratch? A couple of reasons. The first one is educational purpose. That's a valid one. If you need to troubleshoot one, you need to understand, how it works. And the third one may be, well, in our case, we need to talk to an external API, like the Marvel API, which is probably not you want, but like maybe you may depend on your own company API that you want to factor in. In that case, you may want to have this custom controller and build it from scratch. So how does it work? So as I said, it runs as a dynamic admission controller. It runs as webhook configured at runtime. So this is the nice diagram where you see where the different components are called. So you have the mutating admission webhook that is called, before the schema validation, and this is where the validating webhook would be called. So today we're going to be focused on this part. So it can make decisions that may involve external data, and at the very beginning, it needs the mutating admission webhook or the validating admission webhook admission controller to be there in the first place, meaning that the dynamic admission controller, if you want to build one, also depends on this admission controller to be enabled as part of the API server argument, which is the case by default, right? So unless you modify it manually, then you should be good to go. So that was the part for the basics. Now let's get a bit into more code. So the admission webhook. So basically, what is a webhook? Hopefully everyone knows, but just in case, HTTP over TLS in our case. So TLS is mandatory, where the API server is calling out the webhook. It's based on HTTPS. To send real-time data to the custom admission controller. And this is the main object that is sent to the webhook, and also that is sent back to the API server. So this admission review there, this is the object that we're going to be working with. It does have two types here. So we have a request object and a response object. So the request object is populated for incoming requests. And incoming request means that the requests that are coming into the webhook. And the response is what you have to populate from the web server when it's talking back to the API server. So in terms of the process, this is what the request payload look like. So you will find so this is coming from the API server. You will find the request ID, the kind of object, like the same that you have in the manifest. Here you see the resource, so it's kind of the same thing, but this one is the resource as defined, in the URI from the API server. So the resource as part of the API path. You will find the namespace. The operation, which is quite important, the user information, so who has requested that particular object. And you will see, in our case, we want to modify any pod by adding the label. And this is where you will find the pod specification. So now, this is what is expected by the API server in the case, again, of the mutating webhook. Here, we will find the UID, so it has to be the same as the request ID for sure. Allowed, of course, true if we want to mutate. The patch type, which is JSON patch. So in the end, it's just JSON patching the mutating webhook, right? And here you will see the serialized data, right? So essentially, it's base 64 encoded, like JSON marshalling typical thing. And if you just put it into a Go structure, what you would have to build is an array of the different patch you want to implement. So you have the operator, so add the path of the object you want to modify and the value, right? So nothing too complicated. Okay, so on top of implementing the admission review, what we need to do is create a mutating webhook configuration. That's an object that is meant for the mutating webhook configuration controller, where we have to add a couple of things. So first, as it's done via over TLS, we need some certificates. So I would advise you to use Cert Manager because it just takes 5 minutes. And the good thing is there is the CA bundle that is requested as part of the client config, I believe. And just by adding this line here, right, once you have created all the certificate with Cert Manager, is just inject the CA bundle from Cert Manager directly. So it's very easy. And on the other side, we're going to see that because Cert Manager put all the required information as secrets, you can just mount the secrets into your webhook server, like pod that is running, and then you have all the elements that you need, right? So that's very easy to do with Cert Manager. So a couple of things here. You have to add here the path to the webhook server. So this is our HTTP handler is going to run there. The operation that is going to be useful, so all for the pods in the create operation, and the failure policy. This is typically it can lead to chicken and egg issue if you put if you want to enforce it and not put like ignore, like if you put fail. If you create it before you deploy the pod responsible for the webhook, it's going to fail, right? Because the webhook is not there, and if you apply that configuration, it's going to fail, of course, because when you're going to apply the webhook manifest, well, it's chicken and egg. It's not there yet, and you're trying to deploy it, right? So it's not going to work. So ignore is probably where you want to start with. And of course, if you can afford it, we're going to see like some security best practices at the end. You may want to do like a fake close with fail, right? Okay, so now that we have all the components, we can start building our webhook server. So the main function in our Go code for the webhook is going to be that one. So nothing really fancy, just to have so of course get the certificates. We want to build the handler there with the endpoint there, and just serve this, right? And there we just listen server TLS. This is where we run essentially our web server with the certificates, just as parameter. So a couple of things that we need to do in our code. I'm going to show you just after in the demo anyway the whole thing, but the most important part are really here the patch operation, which is what we've seen before as part of the admission review. Operation is add in our case. We want to do labels, so we can sort of hard code this. The value here is new labels. So this is the tricky part. At the beginning when I did it, I was just like creating my label, which was deleting all the other labels. So I had some issue when doing testing with the deployment, because then I was rewriting the label on the deployment, which means the deployment controller never found the pod corresponding to that deployment, and then it's like the death loop. Like all the pods are created in a loop, and that never stops. So you have to be careful there. This is, you want to implement some logic that we're going to see in a minute. So then you need to serialize the JSON patch to JSON. Here, to serialize what you have there. Then, of course, you want to inject this into your admission review response. So you have the patch byte here, but by just doing JSON marshal in Go, we'll encode it in base 64. So there's nothing more you need to do to add your parameter, your property there, right? And then, again, you need to serialize the admission review this time, again with JSON marshalling, and then send that admission review on the wire via HTTP. You set the content type application JSON. Although yesterday we've seen that even if you don't do that, the API server, that won't cause an issue, but still good practice to do it. Write header HTTP status OK and send the response. So nothing really too complicated in Go. And a couple of remaining steps. You need, of course, to build the container image. You need to wrap it up into a deployment manifest because you need to cater for some sort of HA, right? Not naked pod. And of course, because as always in Kubernetes, we need to point things to a service. You need to build a service manifest. So cluster IP, you don't want to create your pod, like we're running on a privileged port. So you want the service on 443, but the target port in your container, try to use an unprivileged port. OK, so I'm going to just switch to the demo. So hopefully it's going to work. So this is the whole project I have built. So at the very, oops, why didn't switch? OK, let me. OK. There you go. OK. So we have our Docker file, but I want to show you something a bit different today because, yeah, Docker file is overrated, I would say. No, I'm just joking. So we have our main project with CMD, traditional Go structure. The main.go, which is essentially the handler function, logging the listen and serve TLS here. And then the webhook.go, which is defining our function. The handle add Marvel label here. So if we look into the details, again, the patch operation that is there, the handler function, this is the main, the core of our function. We just read the request body, deserialize the request body into the admission review object, then extract the raw pod object from the admission review to get the list of existing label and add our label on top because you don't want to make the same noob mistake I did, which is rewriting all the labels. Extract the metadata field from the pod object. So here is just like serializing this into a map of interfaces, like arbitrary data that you can navigate through here, metadata. Check for the existing label. And then I'm just going to use the Marvel API URL and build that particular URL you need to do. So you need to have the hash function to call the Marvel API. And then you need to do a couple of things because it's paginated. So here I'm just taking like 800 characters. It's just not named. There's a lot of information. What I didn't manage, because it's simple code, you should manage, retries, timeout, all those sort of things. It's just like I set a number that I know I won't get any timeouts, and my admission controller is happy because it's just quick and dirty. But definitely that's something you need to manage. We're going to see in the best practices. But timeout is really one core component of the things you need to pay attention to. Then create a new map for the label. And just sanitize the answer from the Marvel API because a label cannot have space, I believe, right? So you need, here I'm just replacing space by underscore. And then this is, the final part, which is serialize the JSON patch operation to JSON, as we've seen. Construct the admission review with the patch bytes that is there. And again, now that you have the admission review, serialize this into the response byte and send it over the wire, right? So it's quite simple. So in the deploy folder, I have all the required components for managing all the certificates. So with Cert Manager. So typically you need the CA bootstrap. You need then to bootstrap your CA. Then you need one root CA. And then you need the root CA issuer so that you can issue certificates to other entities, in our case, the webhook. And that's basically it. So it's really nothing fancy. It's quite easy. DNS name, of course, it needs to match the service that you're going to build, the service object in Kubernetes. So that's not really complicated. And then the webhook configuration, couple of manifests here. So as we've seen the mutating webhook configuration, we've seen this one. The deployment, so really easy deployment. You can do just like a create, kubectl create deployment, dry run, from server and add, a couple of information to the picture. So the container image, of course, the Marvel private key that I've hidden there, the container port, because I want to run this on an unprivileged port, the volume mounts to mount the secrets from cert manager, right? This is the only thing that I need, and then the service. So from 443 and just target port, this is my webhook server port from the container, right? So today I just wanted to show you Earth file. So who is familiar with Earthly? No one? Really? Okay. Stephen, okay. So the definition of Earthly, how they define it is like if Dockerfile or Dockerfile and Makefile had a baby. It's exactly that. So, instead of having both Makefile and Dockerfile, you just build everything into Earthfile. So the idea is that one. So here you have your target, like in a Makefile, build, test. So I've got like a Go test just to test my my Marvel, API is working without to have, all the logic of the code. And so in Earthfile, you can build all those targets, but every target, it's a container, right? So it's Docker sort of syntax. And it's just adding layers on top. So you start with your basic instruction. So from Golang latest, work the app, just copy the dependency, download, and then I define my different targets, which are going to continue to build on top of that, right? So here, build, just disabling the Cgo because I want to run a distroless container in the end, so I have to have everything static. And then you can save artifacts to reuse them later in the different targets. So it's pretty neat. It does have caching. You don't have to, as you can see here, it's using build kits behind the hood, but you don't have to type the buildx command, which kills all, it's every time I found it a bit, just time consuming to do all of that. And with Earthfile, then you can just do Earthly push, which means that I want to push it upstream. The target, which is all is defining the build, the tests, and the multi-architecture. If I just do that, hopefully internet is working. No, it's not. Yeah, okay. Of course. I'm not in the right directory. Okay, it's just that, hopefully. This is, okay. Cross finger. Everything is in cache. I didn't modify anything, so it should be super fast. Okay, done. So I found it's also, faster than Docker in general, or So try it out. If you want to try something new that can save time, Earthly may be a good option. So here, what I've got now, it passed the tests. I've got the image that got pushed into my repository, and we should be good to go. So how much time do I have? It's like 5 minutes, right? No, it's already. 7 minutes, okay, good. So here, let's delete, this is my deployment. Let's delete the current one, right? So let's assume I don't have my webhook there. And now let's deploy. Let's go into the deploy directory. We are here, let's go in the webhook configuration we have here. Okay, so this is going to deploy all the service, which is, already there, unchanged. Created the deployment, so I should see a new deployment there, which has 1 pods. So I've got my Marvel pods running there, no log yet. Now I can start creating, you want to test it with different things, so let's start to have pods there. So Nginx, like naked pods, I'm going to create 10 pods. So if we look at the API server logs, we should see things coming out, like here, sending things, calling mutating webhook and getting some responses. All right. And if we monitor our Marvel webhook, we should also see here admission review. And if I was to, like here as an example, echo, let's do this, base 64 decode. Right, if you want to see a bit better. So this is exactly what we want, right? The operation, the path, and the value that has been added into my label. 5 minutes, cool. So now, if we check the pods, all our Nginx description, I should have like the original label plus a new Marvel label for all of them. Just have a quick look. Yeah, it seemed to work well, okay. Now, I also want to test this into a higher level of, like controller. Like, let's test with a deployment if it's working. Create a deployment Nginx just with 2 replica. So I should see 2 new pods coming up from the deployment controller. Taking some time, working, yeah. So here it's working as well, so I don't have my loop of death anymore. So I'm happy with this. So yeah, so the demo worked. Now, a couple of things about the things I've learned and what you should do if you want to do some more production-ready admission controller. So first, you want to check this link, which is, I think, part of SIG security, I believe, link, where you have all the threats model for admission controller and all the possible mitigation solution that you can implement. So of course, one of them, webhook fake close when possible. If it's, depending on your environment, it may be possible or not. It's always a trade-off between security and flexibility, right? Availability and security are 2 different things that don't go well together, so you have to find the trade-off. I didn't implement it, but you can also implement mutual authentication. So, of course, our webhook needs to be authenticated against the API server, but you can also authenticate the API server against the webhook. So the webhook knows that the API server is legit. For this, it's just a configuration you have to create on the API server and specify it as the API server argument. So not very difficult to do. All back in place for mutating, validating webhook objects. So for the deployment, keyless encryption, of course, is mandatory anyway. Verify the webhook server external API calls, like I'm calling Marvel APIs. Maybe it's not allowed in your environment, and that should be the case. No public API from the Kubernetes cluster. No multi-cluster webhook server, so you should limit. Again, it's a design decision, so it's and every decision can be discussed for sure, but typically a standard practice would be don't create a webhook server that manages multiple clusters. GitOps processes must ignore mutated properties, right? If you have Argo CD or anything that sees a new label or something mutated has been implemented, well, the first thing it's going to do is revert back. So you have to create some sort of exceptions and not, or set it to manual, right? There's different way to manage this, but you can create exceptions, like ask Argo CD not to check for specific properties. That was for security. Now more for around operations. So of course, test your webhook with different controllers. If you're, for example, for pods, test also deployment, jobs, and other controllers. Be aware of timeout settings. So I didn't implement any timeout here, which is really bad practice. So you can set up timeout into the API server configuration via the admission configuration object. Webhook configuration timeout via the mutating webhook configuration or the validating one. You can also set timeout there. You can set up timeout into the HTTP handler in Go, and this is where you should also handle the timeouts. Design for HA, immutability is mandatory. I didn't implement it in an immutable way, meaning that if the pod already has a Marvel label, it will just create another one. So that's another key aspect you have to have in mind. Rate limiting, also that would be a best practice into the Go code, and configure the appropriate Kubernetes resource settings for the webhook server. That would be all the consideration. Maybe There are others, but at least this is all the one I came up with. OK, so if you have to remember something from today, I don't know which part you focus on amongst your 10 minutes attention span. But yeah, admission controllers are built in by default either as part of the API server, compile, static ones, or as dynamic or custom webhooks. They can be used to validate or modify Kubernetes objects. We've seen the main object that we've been working with is the admission review. So this is what you want to take a look at. And in the end, the webhook server is just an HTTP server. And finally, possibilities are endless, but there are numerous considerations for running custom admission controller if you want to run them in production. So a quick marketing webhook. My webhook is so what we do as Spectro Cloud. If you have any sort of static manifest or additional manifest like webhook you want to use, you can do it via cluster API that we use and can just be part of a layer in our stack. So if you want to test it out and implement your own admission controller via manifest, you've got this QR code. We provide cluster for free. And that's essentially it. Yeah, thank you first.